This is concept 38 part 2. In this one we discuss the properties of squares. A square has all the properties of a parallelogram, rectangle, and a rhombus. So these are the 5 of the parallelogram, these are the 2 from the rectangle, and these are the 3 from the rhombus. So pause the video and just familiarize yourselves with these properties here. And when you're ready to continue, all the properties here make working with squares the easiest one of the quadrilaterals we have seen so far. If ABCD is a square and AD is 11, find each missing value. So AD is 11. So I'm right here. So it's a square, so all 4 sides are equal. So I can just label 11 all across all 4 sides. BC is the other side of AD, so it's just the other length of the square. So I could just say this one's 11 as well. AC is this diagonal here, the blue one. So then if I have this triangle here, I can use Pythagorean theorem to find what AC is. And I'm also going to say, I'm going to label my 4 angles, my 4 corners, as right angles, because according to the rectangle property that's part of the square is I have 4 right angles. So I have that one there, I have those that way. And then if I'm using the blue triangle, I can use Pythagorean theorem, and I'm missing my C. So to find AC, I have 11 squared plus 11 squared is equal to C squared, and I have 121 plus 121, that's equal to C squared. Then I get 242 is equal to C squared. And then the way I would solve for C is you take the square root of both sides, okay, and then this gives me C. C is equal to the square root of 242. So just hang on, let me go get a calculator. So then the square root of 242, you're going to get 15.556, and you want to round, so if I round this I get 15.6, and it's that one. BD is the other diagonal, and according to the properties here, diagonals are congruent, they're equal. So if one of them, the blue one, is 15.6, then I can say that the other one is also 15.6. And then EC is half the blue diagonal, so 15.6 divided by 2, and you're going to get 7.8. The measure of DAB, so DAB is the entire corner, so I have a right angle, it's 90 degrees. AEB is this central angle here. Now the square has the properties of the rhombus, so diagonals are perpendicular, they form 90-degree angles. So that means I have a 90-degree angle there, I have a 90-degree angle there, another 90-degree angle there, and another 90-degree angle there. So it looks like there's a little square in the center. So all 4 angles are 90. So AEB is 90. It would be that one there. CBD is this half angle. Now diagonals bisect opposite angles. That means they're cut in half. Okay, so each corner here, the diagonal cuts it in half. So you can say that you have 45 degrees. You have 45 degrees going all there, because 45 plus 45 is 90. So CBD is 45 degrees. BAC is the other one there, so it's also 45 degrees. Number 7 says if PQRS is a square, TR is 17. So then, I'm gonna use blue. This guy here is 17. Find each missing value. PR is the entire diagonal. If half of it is 17, you can say the other one here is also 17. So combined, they're 34. QS is the other diagonal, and again, we already said that diagonals, right here, the diagonals are congruent. So this one's also 34. QT is half the diagonal, and because the diagonals are congruent, you can say you have 17 on all 4 of them. Okay, so half the diagonal is 17. PQ is the top side here. Now, reminder that I have right angles all in the center there, and then my corners are also right angles. Okay, so I'm going to highlight in blue. I can take this triangle here and use the Pythagorean theorem to solve for PQ. So I have 17 squared plus 17 squared is equal to C squared. Oops. 17 squared, you're going to get 289. So 289 plus 289 is equal to C squared. Yep, 578. Then you take the square root of both sides, and you get that C is equal to the square root of 578. And I get 24. You get 24.04, and the way you would round this is 4, so you round down. So you could just say it's 24. All my angles here should be labeled PRS. PRS is this one here, and we already said because the angles are bisected, you can also say that each small angle going all around, the square here are 45, because again 45 plus 45 is 90. So PRS is 45. STR is this central angle here, that's 90. PSR is the entire corner, so it's 90. QPR is this upper left corner there, so it's 45 degrees. Not the entire corner, it's just half the corner. And that wraps up number 7. Number 8, I have if MNOP is a rhombus, find MP. MP is right here, this guy. Now we know in a rhombus that all 4 sides are equal. So I have this expression, all sides are equal, so I can set those equal to each other. So I have 9x minus 77 is equal to 3x plus 7. I solve for x, subtract 3x from both sides, and I get 6x minus 77 is equal to 3x, whoops, not 3x, that's equal to 7. I add 77 to both sides, that's equal to 84. And then I divide by 6, and I get 14. But I'm not done. It says find MP. So now that I found x, I can plug it in to either the top or bottom. I'm going to plug in the bottom because they're smaller. Okay, so to find PO, plug in 3 times 14 plus 7. I get 42 plus 7, and that's equal to 49. But again, all 4 sides are the same, so if this one is 49, MP, the one we're finding, is also 49. Number 9, CDEF is a rhombus. Find the measure of angle FED. So FED is this entire angle here, the red one there. So let me see, here are the rhombus. Diagonals, here we go. Diagonals bisect opposite angles. So this angle here was cut into two equal pieces, and also the one that they give me with the expressions are cut into two equal pieces. So 5x plus 1 is equal to 8x minus 20. And then I solve for x, I subtract 5x from both sides. I get 3x minus 20 is equal to 1, and then I add 20 to both sides, and I get 21 is equal to 3x, and then I divide by 3, and I get that x is equal to 7. But I need to find the measure of FED. So to find FED, I can plug my x that I found, into either angle here. Let's plug into this one. So 5 times 7 plus 1. Again, I'm plugging into the top one. So I get 35 plus 1, and I get 36. So this angle here is 36. And I know, again, that my angles are cut in half by the diagonal. So this one is also 36. 36, 36. That gives me an entire angle of 72. Okay, so then the entire corner here is 72 degrees. This angle here plus this one need to equal 180 because they are consecutive angles and they are supplementary. So to find the measure of angle, FED, that's equal to 72 plus, and let's call this x for now, okay, plus x, that's equal to 180. And if I subtract 72 from both sides, I'll get that x is equal to 108. So that is angle FED. For the last two, I have if STUV is a square with SW is equal to 2x plus 3 and WU is 8x minus 41, find VT. So VT, let me use blue. SW is this guy here, 2x plus 13. Again, that's this guy here. WU is the other half, 8x minus 41. That's this guy here. The diagonals are clearly they're bisected, so they both have to be equal. So I can say 2x plus 13 is equal to 8x minus 41. I solve for x, I subtract 2x from both sides. I get 13 is equal to 6x minus 41, and then I add 41 on both sides, and I get 54 is equal to 6x. If I divide by 6, I get x is equal to 9. But it says find VT. VT is the entire other diagonal. I know that this diagonal has to be equal to this one. So I plug in x to either the top or bottom. I'm going to plug into the blue one. So SW is 2 times 9 plus 13. 18 plus 13 is 31. That's equal to 31. That's half. So SU, the entire diagonal, okay, needs to be double that. So SU is 62. And again, VT is equal to the other diagonal. So then VT is also 62. Finally, the last, number 11. FGHI is a square, solve for x. Now this one is as quick as you know your properties. Okay, we know that in a square, all four corners are 90 degrees. And we also know that the diagonals bisect these angles, so each half angle has to be 45 degrees. You have 45 degrees going all around. So then this angle, 7x plus 3, is 45 degrees. And you can say 7x plus 3 is equal to 45. Subtract 3, I get 7x is equal to 42. And then if I divide by 7, I get that x is equal to 6. And that's it. That wraps up concept 38.